Hello everyone, welcome to Automation Industry 4.0 YouTube channel. This is a series of industrial robot arm programming session, and we are in session 4. In this session, we want to develop a program for an industrial robot arm to pick a cube. So in this project, we want to use one type of ABB robot, CRB 1300, 7 kg and 1.4 meter for reachability. So this robot is made by ABB. The brand of robot is ABB. Model of the robot is CRB 1300. This type of robot is has a 6 axis, and payload for this type of robot is 7 kg, and reachability is 1.4 meter, and repeatability is 0.03 millimeter. Weight of this robot is 79 kg. So in this session, we want to develop a program to pick a cube, and the next session we want to develop a program to pick and place. So we want to go step by step, and in this session just we want to write a program, and we want to develop a program to pick a cube, and in the next session, session 5, we want to develop a program to pick and place. So we want to go step by step, and to learn a student and learner to have a good skill for industrial robot arm programming. To write a program for industrial robot arm to pick a cube, now I will start with file new station, create a new station, and in this environment we need to put our component. So before to write a program, I have some presentation here to explain which step we need to have to write this project code. So the first step in this project is choosing of the components. So we have 4 components in this project to put in the RoboDK environment. So the first component is ABB robot, and the next component is the robot gripper, RoboTQ, and the other object and component we need to have in this project is cube 100 by 100 millimeter, and the last component is table we need to put in this environment of the RoboDK. So as you can see here in this picture, I highlighted here, and we have an ABB robot, we have a RoboDK, cube, and table as well. So this is the first step. All of the components we should put in the RoboDK environment, and the next step and second step, we have to create 2 framework. So the first framework is based framework. In the base framework, we want to put a table, and the other framework is I rename it to part 1. So in this framework, we want to put some target here. So overall, we have 2 framework, base framework and part 1 framework. So in the second step, we have to do this thing and create a framework. The third step, what is the third step? In third step, we need to create some target. So for example, the first target of the robot would be home position. So we have to create a position, and a position such as the home position. Robot will be at the home position, and the other target would be approach to the object. We need to create that, and the last target would be pick position. So it means that a gripper can take and pick a cube. So we need to have 3 targets. This is the third step. So the last step, we have to make a program to pick an object or cube we have in this project. So after creating, put a component and create a framework and create a target, the last step, we want to write a program, and we have to write a program. This is the last step. So let's start with the RoboDK. So let's start the RoboDK. When the RoboDK is open, now we want to write a program and code for industrial robot arm to picking a cube by a gripper and industrial robot arm. So for this project, we need to do some step. I want to show you which step do we need to write this type of project code. So the first step for robot code writing is choosing our component. In this project, we need to have some components such as the ABB robot, CRB 1300, and the other one is a gripper. We need to have a gripper, and then the other component we need to have in this project is cube 100 by 100 millimeter, and also we need to have a table to put the device on that. So 4 components we need to have in this project. Next step, and the second step, we have to create a 2 framework. The first one is based framework. The second one is part 1 framework. So as you can see here in this picture, we need to have 2 framework, and we will create a base framework and part 1 framework. I'll show you in the software. In the third step, as you can see here in this slide, we have to create some target. For example, in this project, we have a home target. This is the home position for robot. And approach position, it means that robot can be close to the object, and the last position would be peak position. In this position, gripper can pick the top, can pick the object, and can take the object to move that. So for the so after create a position and the target, the last step to do in this project is we have to make a program. After creation a position and framework in step 2 and step 3 position, and last part we need to create a program and write a program in this step. So let's start with RoboDK, and let's go to the RoboDK, and here I want to start the program. So go to the file, new station. I create a station here, and then as I mentioned before, we need to select all components. So go to the library, and library connected online to the online library, and in the online library we want to choose the ABB robot CRB. I write it here and search it here, and the first one, download the object. The object is the component is downloaded here. The other one is gripper. I want to choose a gripper. Also the name of gripper I mentioned here in this slide. Gripper RoboDK. Let me search gripper RoboDK. I think I can take it earlier. This component we need to have in this project, so download it. The next one is cube, as I mentioned here in this slide. The next one is cube, 100 by 100 millimeter. I search it here. I hope to find that. Yes, this one is 100. So this one is 50 millimeter. This one is 100 by 100 millimeter. Download it. And each component I download that I want to put in the environment, in the RoboDK environment. Double click on that. The component is here at the moment. So the next component is RoboDK gripper. When I double click on that, RoboDK gripper is attached to the flange of the robot. Next component, I want to put the cube and table. Let me search on the table. Last component we want to have is a table, this type of table. I mentioned before, this table we need to have in this project. So this table, download it and double click on the table. The table is appear here. The last part we need to have is cube. So double click on the cube. Cube will be in this position. Also we need to move it. For example, I want to move the cube in other section to be appear better. So here we have all of the component we need. So we have a cube, we have table, we have industrial robot arm, and we have a gripper here. So all of the component we have here, and now we need to go to the next step. Next step, as I mentioned here, second step is create two framework, base and part one. Okay, so all of the components we need in this project, such as the ABB robot, robot gripper, cube, and table, we put in this environment and RoboDK environment. Now, I want to create, let me check the presentation. In this presentation, as we mentioned before, in this step, we need to create a framework, two framework. One of them, the name of the framework would be base, and the other one would be part one. So here, I want to create two framework. One of them is base, and one of them is part one. So let's go to the RoboDK and to do that. In the RoboDK, first click on the ABB CRB, press here, add a reference frame number 2, rename it to, as I mentioned before, base. Let me name it to base. So base framework is created right now. Next work I should do is to reset the framework. After reset the framework, I want to put the table in this framework. Okay, again reset or double click on here, and in this point, in this icon, we can find the reset here and reset. We have two options. One of them is here to reset, and other one right click and find the reset to reset the base. So this framework is ready. So other framework, I have to create it. Double click on the ABB robot and add a reference frame to create a reference frame part. Rename it to reference frame part 1. So reference frame part 1 is created, and here we have two reference frame. One of them is base, one of them is part 1. Now I want to put the cube in this reference frame, part number 1, and then want to reset. We have two options to reset. Double click on the part 1 and reset from here, or right click and find the reset here to reset the framework. So all of work is down here right now. The next thing I want to do that, press Alt and move the robot in the corner of the table. I want to put the robot here the corner of the table is the right position, to pick a cube. So release the Alt and rotate the robot and table. You can see robot and table is here. So again reset and again. Okay, great. Next option I have to do to create a target. Let's go to the presentation. The third step, we have to create targets. We have to create 3 targets. One of them is whom. We have to create it in the based framework. 2 target we have to create in framework part 1. One of them is approach, other one is pick or take a cube. So we need to create 3 targets here. Let's go to the RoboDK and to do that. So in the base framework, I want to create a target here. The name of the target would be home position. Before to do that, I need to do something here. Double click on the robot and rotate the robot gripper in the right position to grab the cube. At the moment, gripper direction is this in this direction. I want to change it to grab the cube. So double click on the robot and put it here 90 degree. Robot direction would be down. Robot gripper direction would be down and is suitable to grab the object. So I did it here. Let me a little move the robot gripper. Let me a little move here. And so all of things is ready to write a position. The first position we want to create in the base is a home position. Robot in the first place would be home position. Click on the base and press on the target and right click, rename it to home or home position. This is the first target. The robot is in the first target or home position. So next target we need to create in the part 1. We need to create 2 targets here. One of them is approach. It means that we are closing to the cube. The next target would be picking or take a cube or grab the cube. So we need to create 2 targets here. So before to create a target, I want to change the robot position. It's very close to cube. Let me check. Maybe here should be fine. Let me check. A little move in this direction, a little move in this direction. I think it should be fine. So release the Alt and press the target. The name of this target, rename it to approach or up. It means that we are closing to the cube to take it. The last target would press Alt and grab the cube. Let me check. Grabbing. I think should be. I think it should be fine. So target. Not this one. The part 1 target and rename it to pick. I created all of the target we need in this project. Let me check the target that it works or not. Home, approach, and pick. Okay, great. All of the target is created here, approach and pick. Okay, great. Next step. So what should we do in the last step? We have to make a program to pick and cube. We need to have a program number 1 to replace the object, replace the cube in the first position, in the reset position, and the program number 2, we want to write a main program. So we need to create 2 programs, program number 1 and program number 2. Program number 1, let's go to the RoboDK to create a program number 1 and program number 2. So press here, add a program number 1. We want to write a command and instruction to replace an object or replace a cube in the first position. Right click in the program number 1, add instruction, go to the simulation event instruction. So set an object position, set an object position here, click on the cube and table and OK. So what does it mean in this this instruction? It means that when you move the cube, for example, I want to move the cube in the, I want to change the Z direction for the cube 100, cube can move here, and after press on the program number 1, the cube should be back to the first position. Okay, as you can see here. Double click on the here again. For example, I want to put a cube and change the X position, and cube is here. Press on, double click on the program number 1. The cube should be back in on the first position. Double click, yes. As you can see here, program number 1, it works as a replace object to the first position. So next program, I want to create it as a main program. It is as a main program. For example, go to the robot in the home position, and from click on the base, home, and program number 2. Program number 2, linear movement. Robot can move from home position to approach position based on a joint movement. Sorry, yes, based on a joint movement. So the next one, from the home until the approach position, I want to write a command or instruction as a move joint. And from approach to the pick position and pick the object, I want to write a command linear movement. All of the component, I write it here. After the linear movement and pick a position, I want to write an instruction to grab or take a cube. Right click on the linear movement, add instruction, simulation event, attach object. Okay, after that, as you can see here, the object is attached to the gripper. After robot take or attached is connected and take a cube, the next position, I want to move the robot to the approach position, back to the approach position after taking the cube. So approach position and as a linear movement. So all of the instruction I need here, I write it here. So double click on program number 1 and double click on program number 2 to see what is the result. So robot can move to the home position and grab the cube and back to the approach position. All of things is done at the moment. So I think robot can work very well. Press double click on the program number 1 to back the cube on the first position, double click on program number 2, and to run simulation again. As you can see here, robot program can work very well to picking a queue. So again, simulation, to see the result, double click on the program number 1.